Okay, great teams. This is example 4, and this one is jam-packed with steps and manipulations that we need to perform in order to achieve the outcome of solving the appropriate value for x. Okay, now what we must remember from the previous video is that when your variable is in your denominator as observed here, we need to have certain restrictions so that our solution does not produce something undefined. So that is the first step, is to find your restrictions. Okay, that is our first step, and I think from here we can see that x cannot be equal to minus 4 and x cannot be equal to 3. Okay, and so as we solve this equation and get to the end of this equation, we need to go ahead and make sure that our solutions do not include either of those values. Okay, and now you might be wondering, well, what about the values here? That will work itself out once we solve this problem. Okay, now I want you to note, in all the previous examples, our LCDs were monomials to a large extent. Okay, and they could not be factorized. So we had things like 2 over x plus 1 over 2, for instance, equals 4, right? Our denominators were single terms, so finding the LCD was straightforward, right? We even had an example where we had a denominator that was, I think, x minus 1, right? And even that we consider as a single term because it's going to produce a single value once we find the value for x, right? And we also cannot factorize it to get it to be a single term. But now in this case we have this trinomial over here that we can factorize so that we end up with one term, because of course, you know, with trinomials, when we factorize them, we ending up with something like this, which we know from grade 9 constitutes as a monomial. So once your denominator is a monomial and it can't be factorized, that is when you find your LCD. And so our first step here would be to factorize the denominators that need factorizing. Okay, in the first term, 2x minus 3 over x plus 4, we can't factorize that, and so that we will consider as one term. Okay, then we have 1 over 3 minus x, that cannot be factorized, so we consider it as one term. But then we end up with, or we see x squared plus x minus 12, which is a trinomial. Okay, and so we look for the factors of 12. We take 3 and 4. I think that is the one that will work for us, right? And if we go plus 4 minus 3, we will get our plus 1 for the middle term. Okay, and so there we have the factors for the trinomial. So I'm going ahead into the next line, and I'm going to say that the denominator is going to be x plus 4 and x minus 3. I'm going ahead and filling in the rest of the terms that are unaltered. So we have 2x minus 3 over x plus 4. And then if you look at this term over here, right, we have 3 minus x, and then we have an x minus 3. Now to make our LCD finding easier, it's better for us to have repeated values in our denominator. So we use our sign changing rule from grade 9, okay, and we make this x minus 3, okay, so that we don't have to work too hard. So I'll make that x minus 3, and then instead of putting the negative over here, I'm going to put it in the numerator with the 1, right? When it comes to fractions, the negative signs placement does not matter, because at the end of the day, this fraction is still negative. Okay, so at this point I have one term in this denominator, one term here, and one term there. Okay, so we now successfully found our restrictions, and now we move on to finding our LCD. Alright, let's go ahead and figure out what we need as our LCD. So your LCD needs to include everything you see in your denominator. So I need an x plus 4. So let's start there. I need x plus 4 and I need an x minus 3, right? And then I go to this denominator and I see that my LCD does accommodate that monomial, my LCD accommodates that one, and my LCD accommodates that one. So this here is the most appropriate and the smallest denominator possible. So that's what we just did. And now the final step before solving is to multiply all these terms by the LCD. Okay, so I just went ahead and multiplied each term by my LCD as indicated by that period there. Alright, and so now we have the following. We have got monomial over monomial, which means we can cancel. We have monomial over monomial, so we can cancel. And then we have another monomial over another monomial, so that we can cancel. Okay, so if you ever forget that you need your denominators to be one term, think about the fact that you cannot cancel unless your denominators are one term. Okay, and without the ability to cancel, solving this equation becomes almost impossible because you'll never be able to get rid of the denominator. Okay, so now let's go ahead and see what we can do. I'm going to cancel the x plus 4. I'm going to cancel the x minus 3. And I'm going to cancel this entire denominator. Okay, at this point I get very excited because now my denominators are completely eliminated and I'm just left with the numerators. Okay, so we need to be a little careful here, and we need to note that 2x minus 3 is being multiplied with x minus 3, so we write it as such. We go 2x minus 3 in its entirety is being multiplied with x minus 3. Do not forget to place that in brackets. Then we go equals minus 1 multiplied by x plus 4, alright, plus 7. Lovely. This we can work with. This is the easier equations. Okay, and so now we go ahead and we solve it. We go 2x squared minus 6x minus 3x plus 9 equals negative x minus 4 plus 7. Okay, I'm going to go ahead and solve this step off camera.